Right, so yesterday we learned, or you guys did the Match My Parabola activity, and so we talked about the three different types of, or three different forms of a quadratic or a parabola. So we're going to talk more about that today. Yesterday you kind of just would like play with the numbers until you could get it to fit. But today we're going to actually find algebraically how you find that value in the front to make it fit your parabola. So anyway, the three types of quadratic functions, which their graphs are parabolas, are standard, vertex, and factored or intercept form. So standard form is when there's no parentheses, so it's y equals ax squared plus bx plus c. And to me, it's the least helpful form. It tells you the least amount of information. It tells you one thing by, if you just look at it, it tells you something. Do you guys remember what C is from Algebra 2? Yes, good. C is the y-intercept, which is helpful, but the other ones are more helpful because you can't really get a whole lot from the graph just from one little point on it, the y-intercept. All right, and A on all of these is going to be the same thing. And A tells you things like how wide the graph is, or if it opens upward, or if it opens downward. All right, so vertex form is, y equals A, and then in parentheses, x minus h, and then that needs to be squared outside the parentheses, and then plus k. Right, this one is more helpful because it tells you the vertex, which is also just one point on the parabola, but it's an important point. It's a point that's going to be the maximum or the minimum. So if you know the vertex and you know if A is positive or negative, if it opens upward or downward, you can get a pretty good idea of what the graph looks like just from those two. All right, I'm also going to throw in the axis of symmetry here. Oh, I'm struggling. Let me get the right word here. All right, so every parabola is symmetric. So if it, like, one half is a reflection of the other, and it's reflected over y, or over the axis of symmetry, which in this case, in all cases, is going to be x equals whatever the x coordinate of the vertex is. So x equals whatever that h value is. And because this original formula has a minus in the parentheses, when you give your x part of your vertex, you change the sign. So anytime, pretty much on these formulas, anytime you pull it out of the parentheses, you change the sign. If it doesn't come out of the parentheses, you keep whatever sign it was. All right, and then the last form is factored form or intercept form. It's probably the form you used the most yesterday. So the A is the same A that tells you direction of opening and width, or height, I guess. And so it's going to be A, and then in parentheses, x minus p, and then x minus q in parentheses. All right, P and Q are x-intercepts. Do you guys know another name for an x-intercept? Just a different word where it crosses the x-axis? All right, it's a zero. So an x-intercept and a zero are the same thing. They're where they're x values that make the function equal to 0. or it's where it crosses the x-axis. All right, so this is nice because it would give you 2 points on the graph, and then if you kind of know if it opens up or down, you can get an idea of what the parabola is going to look like. All right, I don't really remember in your class, but my other class didn't really like having to just guess on those numbers in the front to find it to fit. They wanted me to go ahead and teach them how to do it algebraically, but I wouldn't. I made them guess. But we are today going to find algebraically that value of A. There's actually 2 things we can do. It just depends on what you're given. So to find A, one thing is you can plug in an extra point for x and y and solve for A. That's probably the one you'll do the most. All right, the other one you have to know, bless you, you have to know the x-intercepts and the y-intercept to do this one. It's easier though if you know those. So if you know the x-intercepts and y-intercepts. And I honestly didn't know this formula until last year, but it's really handy to find A. So A is going to be equal to a fraction. In the numerator, you're going to have the y-intercept. And you're going to divide that by the x-intercepts multiplied by each other. Or it's possible I learned that somewhere along the way. I just never have taught it until last year. All right, so the main thing we're going to do today is really look at all the forms and tell characteristics from them. And sometimes we change them to a new form to find things, and sometimes we just plug in values, but all the forms are important. All right, so on number 1, this one is in intercept form or factored form. And in factored form, the easiest thing to do is find the x-intercepts or find the zeros, which is what they're asking us to do. That's the first thing they're asking us to find. Let me start over. All right, so try to remember that if you are pulling something out of a set of parentheses, you're probably going to have to change the sign, and that is the case for intercept form. And so if this is a -3 here, that means the x-intercept is 3. And then a +5 means that the x-intercept is going to be -5. So those will be the 2 places that the graph crosses the x-axis. Okay, and then we're going to find the x-coordinate of the vertex. So we are not going to write this in vertex form. You don't have to do that to find the vertex. And so yesterday you had one where you had 2 x-intercepts and then just kind of a point. It was like you had an x-intercept, and then you had a point right there. And a lot of people were confused because they're like, there's no way that that's the vertex, because you knew that it had to be a symmetric graph. So this was just a random point on the graph. So you already knew that the vertex is going to have to be halfway between your two x-intercepts. So let's jot that down. The vertex is halfway between x-intercepts. So finding the midpoint or the halfway point was one of the first things that we learned this year. So what do you do to find halfway or the midpoint between two numbers? It's been a while. It's probably been since August. You basically find their average, or you add them together and divide by 2. So halfway between 3 and negative 5 is going to be negative 1. So x equals negative 1 is the x coordinate of the vertex. All right, how do we find the y coordinate if we know the x coordinate? It would be the y that goes with that x. You're just going to plug it in. So we're just going to plug the x coordinate into the function, or find f of negative 1. Now you may not have a ton of experience plugging it in when it's in factored form, but it doesn't matter. X is x no matter what form it's in. So just put it in for all the x's, put negative 1 in for all the x's. You're going to get negative 4 times 4, which is going to be negative 16. So that's the y coordinate of the vertex. So now we know the x-intercepts. We know the vertex is at negative 1, negative 16. And we have a really good graph if we wanted to graph this. We can also find one more thing real quick, and that's the y-intercept. And anytime you want to find the y-intercept of any function in the entire world, you're just going to plug 0 in for x. So we basically, at this point, would have 5 points on the graph, and so that would give us a pretty good parabola. And we actually didn't use our calculator to do anything. Okay, so today what we're going to do is, like, I'm going to do one, and then you're going to do one. So you're going to do number 2, which is almost exactly like what we just did for number 1. right, so check yours with mine when you're done. How'd y'all do? Okay, good. All right, the next one is going to be in vertex form, and we're going to do some of the same things. All right, so in vertex form, identifying the vertex axis symmetry is super easy. And so the vertex, we are just going to take what's inside the parentheses for our x coordinate, but we are going to change the sign. And the y coordinate, we do not change the sign. If it doesn't come out of the parentheses, you're not going to change the sign. All right, and then this also asks us for the axis of symmetry. And once you have the vertex, that's super easy to do. You just say that x equals the x coordinate of the vertex. All right, and then part B, we're going to write in standard form. So standard form, we have to multiply everything out and combine all of our like terms. So that means we need to square x plus 6. When I square x plus 6, is that just x squared plus 36? What do y'all think? It is not. So when you square something, when there's addition, you don't just square each part. When you square something, you have to multiply it by itself. All right, and then we're still going to bring down that minus 4 that was on the outside of the parentheses. All right, and then we have to do the double distributive property. So we're going to distribute the x, and then we're going to distribute the 6. All right, and then there's still that minus 4 that drops down. All right, and then our final answer in standard form, we would combine all of our like terms. So that is the standard form. So it's going to require some algebra stuff, multiplying it all out. And then the y-intercept, once it's in standard form, the y-intercept is really easy. It's just going to be the c value or the very last number, or the number that doesn't have an x. All right, so you guys try number 4, please. All right, so check yours with mine when you're done. All right, and so 5 through 8, yeah, is kind of the reverse of what we just did. So we had the equation and we gave characteristics. This time we're going to be giving characteristics and we're going to give the equation that has those. And so if yesterday you didn't really like having to guess and try different numbers to find your equation, this is how we do it algebraically. And so on number 5, we have, we want the equation of a parabola. We want vertex form. We know the vertex, which is great. That's very helpful. And then we know a point on the graph. And so I'm going to just jot down vertex form so we don't have to flip back on our paper over and over again. So this is good because we have H and K. So I can put that in the form. But you don't have the actual equation until you know what A is. And so there's 2 ways to find A. You can plug in an extra point to find A, the light blue, or if you know the x-intercepts and the y-intercept, then you can use that shortcut. But we don't have that. So what we do have is an extra point, the point 720. And so that is going to be our x and our y that we plug in. So we're going to put 20 in for y and 7 in for x. And then this is great because now we still have an equation. It's got a lot going on, but there's only one variable. The only thing we don't know is A, and that's the one thing we want to find. And so we need to make sure we're careful that we follow the orders of operation, or the order of operations, where we're going to go ahead and do the parentheses first. And then we're going to take care of that exponent by squaring 2. And then from here, it's a fairly simple equation to solve just by subtracting and dividing. So then once I find A, I'm going to go back to this purple one where I had plugged in the vertex and put A where it goes, and that is our equation that has that vertex that goes through that point. All right, so you guys try 6, please. Now this one doesn't turn out pretty. You actually end up with a fraction, and that's fine. A can be a fraction or a decimal. It can be positive or negative. It doesn't matter. Yes, ma'am. Oh, this 4 right here. Okay, so the 3 comes, do you have a plus 3? Because you do the opposite. All right, and then x is 1. So 1 plus 3 is the 4, and then you square that. All right, what other questions do you guys have? So what do you like better, just guessing or just doing it algebraically? Guessing algebraically? I don't know. Okay. All right, I don't think we're going to get finished today, and that's okay. Let's look at 7. So we have this equation, and we are going to do all the forms. And so vertex, factored, and standard form. So let's start with, if we can start with any, we can't really start with standard, but we can start with vertex or factored. I'm just going to start with vertex. So I know my vertex is up there at -2, 9. So before I find A, do you guys think A is going to be positive or negative in this case? It's going to be negative because we got this upside down U. Now, because I know the 2 x-intercepts and the y-intercept, I'm going to find A a different way than what we just did. Now, we can do exactly what we just did if you wanted to, but I want you to see both ways. So A can be found by doing the y-intercept divided by your 2 x-intercepts multiplied by each other. All right, so we can do, what's that, 5? 5 divided by -5 times 1. Or just -1. So we were right, it is negative. Now, if you did not want to put -1 there, you can just put a negative in front of the parentheses and it's fine. Either way is fine, doesn't matter. Now, what's great is once you find A, you don't have to do it again. It's going to be the same A for every single one of them. So now when I'm going to do factored form, I already know that's a -1 that goes in the front. And I know my 2 x-intercepts are -5 and 1. So just like yesterday, you guys practiced this, you're going to do the opposite in the factored form. So since it was -5, we'll do x plus 5. And then for 1, we'll do x minus 1. All right, and then for standard form, we can pick either one of these and just multiply it out. So standard form's all multiplied out. I think the green one's going to be a little easier, but they both will give you the same thing. So I'm going to go with the green. I'm going to let that negative hang out there in the front, and then I'm going to distribute my x. And then I'm going to distribute my 5. And combine my like terms. And then your last step is to distribute that negative. Bless you. Okay. So all three of those, same parabola, just a different form. All right, so you guys do that for number 8, and then I think we'll have to hold off on the factoring until tomorrow, and that's okay.